Hi, this lesson is all about the geology of Mars, and in particular, some of the surface features that we find uh, on the red planet, and what that tells us about the processes that must have occurred uh, on Mars in the past. Uh, and also then how we can start to piece together the geological history of this fascinating planet. To do this, we're going to be working on pages 12 and 13 of your booklets. You're also going to need three coloured pens or pencils, ideally a red, a green, and a blue one. Okay, this image is one that you have on page 12 of your booklet. It shows a small area on the Martian surface. Now, we can see there are lots of features on this surface. So to make some sense of them, what we're going to start off by doing is colouring some of them in. Because if we colour code them, it's going to help us to see the relationship between them. So, with the three coloured pencils you have, I'd like you to identify any craters that have a very sharp edge to them. And I'd like you to colour those in red. Then, can you find the craters that have an uneven or broken edge? Colour those in green. And finally, any river channels you can see, can you colour those please in blue? Okay, if you pause the video now, while you do that, okay, let's have a look at what I came up with when I tried this activity. I started out with these craters with the broken rims, coloured those in green. I reckon there are three that I've shown there. The channels I've coloured there in blue. See, there's quite a few of those. And finally, the craters with a sharp edge, which I've highlighted there in red. Okay, check that you've got a similar set of answers for that task. And then what I'd like you to do is pause the video, because I'd like you to use that information that you've just come up with for this part of the surface of Mars to answer the rest of the questions on pages 12 and 13. Have a go at those now. Okay, let's have a look at some of the answers then to these questions. I started off by asking you about the river channels highlighted in blue. How do we know that these are formed by rivers? Well, if you look at the branching pattern of these rivers and compare them to what we see on Earth, we see they're very, very similar. In fact, this branching pattern would suggest as well that this terrain is quite steep because the angle between the branches is quite acute. If we wanted to confirm that, though, we need something like one of the rovers to visit one of these sites and to find things like rounded pebbles or ripple marks, some evidence of river erosion perhaps, to confirm that these are actually made by flowing water. If we compare the river channels with the green craters, we can see that green craters must be older. The river channels actually cut through them. You can see that in particularly in the green crater on the right-hand side there. So the crater had to be there first for the river channel to cut into it. If we compare the river channels though with the the red craters, we can see that the river channels must be older than the red craters, because we can see several of these red craters that actually cut across, they actually impact in those river channels. So again, the river channels had to be there first. We can work out that the land here must slope to the right, okay, or from the west to the east. Because of this branching pattern, we know that rivers combine as they go downhill. So they're going to join up in the direction that they're moving down. And then to work out the geological history of this area, we can put this information together. So if we look at the three events that we've coloured in there, after the formation of the crust, we see the large craters impacting into that crust. We then have the river channels cutting across those larger craters, and finally the impact of the small younger craters, still with the sharp edges. And if you look at the reason for this, it's all applying an idea in geology that we call a cross-cutting relationship, where one thing cuts across another, it must be younger than the thing it's cutting across. Okay, some of you may have had to go at the digging deeper activity. The older craters, the green ones, tend to be larger because early on in the development of the planets, there was a lot of debris whizzing about in space, still being pulled into the surface. So this early bombardment phase by the meteorites had a lot of large material, which obviously would have been more affected by the gravitational pull. Over time, the meteorites would have got smaller, okay, because it's only the smaller bits that are left over from planetary formation that's flying around. And finally, what this all tells us, well, it allows us to establish a few things about the geology of Mars. We can work out the rock cycle processes. We can make links then with Earth processes using this idea of uniformitarianism. We can work out, as you've just done, the geological history of the Martian surface. Gives us a clue perhaps to the chances of life having occurred there in the past. And finally, possibly, something we'll explore in a bit more detail later, the idea of Mars being a prediction of the future of the Earth, although it would take about 1 billion years. Okay, as we look at the picture of a Martian sunset, we've now been able to work out some features about the surface processes on Mars. Next time, I want to look at some of the internal processes of Mars and what effect that's had on its geology.